Alright guys, see you again. Now let's see this problem. Determine the components of all forces acting on each member of the loaded frame. Yeah, so we have a frame A, B. Yeah, that's a frame, right? Because the forces is on the middle of the member, not only at the joint. While BC is actually can be simplified as a two-force member because the forces only work at the end point of this member. At point B and point C, there is no load in between B and C, so we can simplify BCL frame as a 2.42 force member. Yeah. So the question is actually very simple, just to find all forces acting on each member. But let's add more work on this. Let's say we want to calculate the internal forces from point A to B. Yeah. So first, what you need to do is let's dismember everything. Yeah. So imagine you have a, let's make it thicker, I guess. Yeah, make it thick. And here's the member AB. Yeah? And then at point A, you should have AY, and then you have AX, and then here you have 5 kilonewtons, and then you have a BX and BY. Yeah, okay, because that's spin. But because BC is a two-force member, this BX and BY can be simplified as a one force. Let's call it FBC, that has a 3/3 ratio. Yeah. Okay, and then can you solve the problems? Yes, because you have one unknown, FBC, you have second unknown and third unknown. Okay, pretty straightforward. You can calculate that. How? So first, to make it easy, decompose this into this and this. Yeah, this is FBC times 3 divided of square of 3 square 9. Yeah, it's 18, right? 18 means 3 square root of 2. Why? Because it should be 3 square plus 3 square. Yeah, so it becomes this. And then this one also, FBC 3 divided by 3 square root of 2. Okay, and now let's evaluate the moment at point A. A moment at point A. Why A? Because A has two unknowns. Yeah. So let's do it first by checking which forces generate moment. This 5 kilonewton generate moment with respects to A. And if you see here, this distance, how much? 1.5, yeah. meter, so it's clockwise, so it's negative. Minus 5 times 1.5, okay, that's negative because clockwise. And then minus FBC square root of 2 times that distance, yeah, distance from here to here, total 3, yeah, 3 meters, times 3. Anything else? Yes, this, the above, that's also create a clockwise, so minus FBC square root of 2 times this distance to this distance, yeah, from here to here. How much is that? 6, yeah, 6 equals 0. So that minus 7.5, all right, and then that becomes minus 3 minus 6, so minus 9 square root of 2 FBC equals 0. So your FBC will be minus 7.5 times square root of 2 divided by 9. And then your FBC will be, I'm not sure, let's calculate with calculator. Square root of 2 times 7.5 divided by 9. Am I right? I hope so. So it's a 1.1785. Yeah, that's FBC. Okay, straightforward, easy, right? And then how about AX and AY? Then you can calculate that, right, easily. After you find this, what's next? You can calculate AX using sigma. Let's change color. Sigma fx equals 0. So in x direction there is AX, which is positive, AX, and then plus this FBC, the horizontal projection, FBC divided by 2, square root of 2. Am I right? Yes. Anything else? Nothing. Equal 0. So your AX will be minus FBC. Minus FBC. Yeah, this should be minus, yeah, because there's minus there. So minus 1.1785 square root of 2. That is, let me use my calculator, divided by square root of 2. That is 0.833 positive, yeah, Newton. This is Newton 2. And then that's it, right? Yeah, that is the second answer. And then the third answer is, what should we do next? Sigma Fy equals 0. Next is sigma Fy equals 0. There is Ay, which is positive, and then there is minus 5 kilonewton due to the external load that we give, and then there is FBC, projection in vertical components, so minus FBC times 3, square root of 2, right, equal 0. So your AY will be FBC minus 1.1785 square root of 2 and then plus 5. So AY will be, let me check again. So it should be minus plus 5. 4.166 Newton, and that is a y. Okay, would be positive, right? Makes sense, right? Because 5 kilonewton here, your AX, okay, your FBC, okay. So now that's it, right? That's how you get the reaction forces, but that's not enough. Let's continue by drawing the free body diagram from A to B. Yeah, let's make it this point D, yeah, to make it easy. So let's redraw again the problem. Something like this. You have AY. AY is known, which is 4.11166. And then you have AX to the right, and the value is positive, right? So it's correct. What is the value? 0.833. And then you have 5 kilonewton, all of them in kilonewton, yeah. And then you have FBC, which is minus, so actually the direction is reverse, and that is 1.1785 kilonewton with this ratio of 3:3, yeah. Okay. Okay. So now, how do you make a section for this one? So to make a section, you need to establish first your coordinate. Let's say from here to there, you call it Y. From here to here, you call it X. Okay. So the origin is here, basically, yeah. So now let's make the first section here. The first sectioning is here, yeah. So first section from that for X equals 0, because along that line from A to D, yeah, this is A, this is D, this is B. From A to D, yeah, A to D, that X is 0, Y is varied from 0 to 6 meter, and then you can draw the cutted section like this, yeah. And then imagine this is like the V and M, yeah. So you have this you have this 4.166, you have this 0.833. That's it, right? And then using sigma fx equals 0. Which one is your x? The v, yeah, v positive plus 0.833, that's it, equals 0. Your v is minus 0.833 kilonewton. That's the first solutions, okay, for v. And then your sigma fy equals 0, and that means you have this 4.166 plus n equals 0. Your n will be minus 4.166 kilonewton, and that's for your second. All right, and then evaluate the moment at this sectioning point, yeah, equals 0. So this create no moment, yeah, and m, no moment, only this one. So your m will be counterclockwise positive, and then this also counterclockwise with respect to sectioning point. So plus 0.833 times this distance. How much is this distance? As we say, we call this y, yeah, because the location where we section is a variable, so it can be anywhere from y0 to y equals 6. So your m will be minus 0.833y, yeah, okay, clear, yeah. So that's the first section. That's how you do a vertical like sectioning, okay. So the next sectioning is here, yeah. So now let's do second section. Second section is for during D to B, but in this case now the y is constant. Y is 6 meter, right? Because here y is 6 meter if we calculate from A, yeah? 6 meter. Your x will be a variable. That's from 0 to the location of 5 kilonewton, which is 1.5 meter. 1.5 meter. And then okay. Let's draw this and then this. Okay, and that is the sectioning point, yeah. This is A. Point A, you have 4166, 4166, 0.833, and then if you section like this, this will be your V. This will be your N. This will be your moment. So how to solve this? That's easy. How? Let's do it like this here, yeah? Sorry. Sigma moment at the sectioning point equals 0. So this NV will create no moment. The M is counterclockwise, which is positive. and then this 4.116 will create clockwise, so it's 4.111166 times this distance from here to sectioning point, right, which is x. We don't know which location, but x from 0 to 1.5, so x, and then this one create counterclockwise plus 0.833 times this distance, yeah, that is 6 meters, yeah, equals 0. So your moment will be 4.166x plus, let me use my calculator, 0.833 times 6. Yeah, it's 5. Yeah, it's 5 actually. So this is your moment. How about your V? Sigma fx equals 0. So n positive plus 0.833 positive. That's it, right? And then equals 0. Your n will be minus 0.833 kilonewton. Yeah, this is kilonewton, while this one is kilonewton meter. And then sigma fy equals 0. And then what else? This 4.166 will be positive, plus or minus v, because it's going downward, and then they're equal to 0. Your v will be 4.166 kilonewton. Yeah, so this is your answer. Notes that v is derivative of m with respect to x. So if you take derivative of this with respect to x, it will give you this, yeah, dm over dx. Okay, make sure they have a correct directions, right? That's it. It's pretty straightforward. Yeah, okay. And then the next section is where from 5 kilonewton to the end. Yeah, so I will take the right side. And then this will be 1.1785. 1.1785. This 3, yeah. Okay. And then if you call it that x, this one will be x minus, no, it will be 3 minus x. 3 minus x, yeah. And then if it's going downward, this one will be v and m, opposite direction to this one, because action and reaction. Okay, this one will be okay. And then you can do it again. Sigma moment, sigma fx equals 0, n is negative, and then minus 1.1785 square root of 2, right, equals 0. And then your n will be, let's calculate again, 1.1785 divided by square root of 2, 0.833 negative, and then you take a sigma fy equals 0, then your v plus 1.1785 square root of 2 equals 0. What else? Your v will be this plus this. Am I right? Yes. It will be negative, right? Negative 0.833. And then if you take your moment equals 0, it will be, this m is minus m because it's clockwise. The horizontal component of this guy creates no moment, but the vertical one do create moment. So so it's counterclockwise, so it's plus 1.1785 square root of 2, and then you multiply by 3 minus x equals 0. So your moment will be 1.1785 square root of 2 times 3 minus 1.1785 square root of 2 times x. Okay, so that's your v and m. You get for 3 section. The last part is for y equals 6 meter, but that x is from 1.5 to how much is that? To 3 meters. Yeah. Okay. Clear, yeah? So if you want to draw, let's draw the final one. So from here, phi is it's difficult, yeah. I don't like to draw like this, but let's draw like this. It's negative 0.833. That's v, yeah, and then n is minus 4166. That's n minus 4.166, 0.833 minus until this point constant, while this guy is going like this, going down. Yeah, it's a straight line. Yeah, it's a straight line. Moment is minus 0.833y. So this slope is minus 0.833. Okay, that's for the first one. And then from here to here, you take the second part. V is positive. So V, this is your V, which is, how much is V? 4.166. 4.166. And then your N is negative, from here negative constant, negative 0.833, that is your n, and then your m from here, so it's something like this. Yeah, so there is an initial value. If you put x0, it will be 5, so there's a value of 5, and then the slope is 4.166. Yeah, you can draw a different curve. Yeah, but I try to make it everything all in one. Okay, this is not like this. This is until here. Yeah, because this n, the same n. Yeah, n is still the same, correct? V will be different. Where is your v? V will will change. So here v will be negative, so this is wrong. So from here is 4.166, and then v will jump 0.833. Yeah, and then this one will be 0.833, and then your moment will be like this. If x, you can calculate yourself, but I guess this is something like this. Okay, draw nicely. Yeah, I'm too lazy to draw it again. So yeah, but at least you know the idea. If you don't like that, just make a curve like this. This is y, this is n, v, m. From y0 to y 6 meter. Draw the equations, and then you do it again for x from 0 to 3, and this is v and m. Yeah, do it nicely like that. It's more easy for you, I guess. Yeah, and follow these equations. That's it. Thank you. So please practice a lot.